What if I told you there is an object in the universe so massive that even light struggles to escape it? Meet TON 618, one of the largest known black holes in the universe. Its mass is estimated to be tens of billions of times the sun. Now, here's the crazy question. If you tried to orbit TON 618 using a car, a plane, the International Space Station, or even light, how long would it actually take? Let's break reality down.
Before we calculate anything, we need to understand something important. Orbiting a black hole like TON 618 is not like orbiting Earth. You're not just going around a planet, you're circling a region where space itself is heavily warped. The further you are, the easier the orbit. The closer you get, the more extreme time dilation and gravity become. So for this thought experiment, we'll imagine a safe orbit far outside the event horizon, where stable motion is possible. Now let's bring in our vehicles of imagination.
Let's start slow. A normal car moves at about 100 kilometers per hour. On Earth, that feels decent. On a highway, even fast. But around TON 618, we're talking about distances measured in billions of kilometers for a single orbit. At car speed, one orbit would take thousands to tens of thousands of years, possibly even longer depending on orbital radius. That means ancient civilizations would rise and fall. Entire empires would vanish. Humanity itself might evolve into something unrecognizable, and your car would still be halfway through the journey.
Now, let's upgrade. A commercial jet flies at around 900 kilometers per hour. That's 9 times faster than a car. Sounds good? Not really, because space isn't forgiving at this scale. At airplane speed, one orbit around TON 618 would still take hundreds to thousands of years. You would literally board the plane, take off, and never complete the journey in a human lifetime. Even generations of pilots wouldn't finish the trip.
Now we step into real space technology. The International Space Station, or ISS, orbits Earth at about 28,000 kilometers per hour. That's insanely fast compared to anything on Earth. But TON 618 is not Earth. Even at ISS speed, one orbit could take decades to centuries. Why? Because the orbital path around a black hole like this is unimaginably large. Even at high speed, the distance dominates everything. So you might start your mission, but you will not finish it in a human lifetime, or even several lifetimes combined.
Now we reach the ultimate limit. Light. Speed 300,000 kilometers per second. Nothing in the universe is faster. So surely light wins, right? Yes, but even then, space wins in its own way. Depending on the orbital distance, light could take days, months, or even years to complete a full orbit around TON 618. But here's the mind-bending part. Near a black hole, time itself slows down. Light bends. Paths curve around gravity wells. So even light is not simply straight-line fast anymore. It is trapped in geometry shaped by extreme gravity.
TON 618 is not just big. It is a cosmic scale breaker. To understand it, cars, meaningless over thousands of years. Planes, still too slow by cosmic standards. Spacecraft, powerful but still limited. Light, fastest thing in existence, yet still affected by gravity. This shows us something profound. In the universe, speed is not everything. Distance and gravity reshape reality itself. So, next time you think about speed, remember TON 618. a place where even light bends and time itself slows down. And maybe the biggest question is not how fast can we go, but how does the universe allow anything to move at all?